Okay, so let's learn about vectors. This is on your page 6, and this portion is called Applications of Vectors. So within this video, I'm going to explain what bearing means as well as what vectors mean. Vectors are, as we've seen before, is basically the distance with direction. And we represent our direction with angles, and that's how we represent directions a lot of times in math. So let's read this prompt together. It kind of explains what bearing means. Bearing is a measure that measures things starting from north and clockwise. So let me show you what that means, okay? Usually, so this is our regular one. I'm going to draw this for you. I'm going to have two different planes. So this one is my usual one, which means my 0 starts here. And you know this is your 90 degrees, and this is 180 degrees, and this is 270 degrees, and all the way around it with 360 degrees. That's a usual plane that you know we use in unit circle. However, the bearing part is a little different. So let's go ahead and draw our little plane. So within a bearing portion, our 0 changes. Our 0 is at north. So 0 is at north. So imagine yourself driving. If you're driving, you'll be looking at the front, and you'll refer to your front as your 0. So front is your 0, and your right side would be your 90. So it's go clockwise. So this is how the bearing works, clockwise. And this is 180 here, and 270 there. And once again, if you go full circle, that makes a 360 degrees. So this blue part is what we refer to bearing. In bearing, nothing really changes. So the corner points are still the same. It's still positive, positive here. This is still your x-axis, still east, west, north, south. This is your negative, positive, still negative and negative, and this is your positive and negative. Okay. The only thing that changes here, though, would be your angles, and I'll show you what I mean by that throughout an example that we're about to go through. So on number 1 here, this is what it's telling us here. So it says 11 miles north. So we're going to draw that. So our vector for this one, because we're going to have so many different vectors, we're going to go ahead and label our vector. This first one, let's label it with U. So let's say that's our vector U. Our vector U, it says 11 miles north. North is from 0 here all the way to however many miles 11 miles is. So let's say it stopped there. So the distance from here to here is 11 miles. However, my vector U can be expressed in coordinate points. Our coordinate point, since it went up 11, it's going to be 0, 11. Now let's do the same thing for our next vector. It says 6 miles along a bearing of 70 degrees. So let's try to draw that one. So on our thing, on our axis, okay, since it's bearing, I'm going to go ahead and make myself little notations with degrees so that I know what's what. That's 90, 180, and 270. And I'm going to go ahead and label this vector as V, so that way I just can refer back to it if I wanted to. It says bearing of 70 degrees, which 70 degrees is in between here to there. So if I were to draw a vector, it's going to look something like it. With 6 miles, that's a distance of 6 miles, with bearing 70 degrees. Now the 70 degree representing from 0 to this vector is 70 degrees. Okay. but nothing really changes from your other vectors that we've seen before. Every time we have a segment like this, we drop a perpendicular line to the x-axis. That's where you drop the perpendicular. Every single time you're dropping a perpendicular line to the x-axis. Now, if you're wondering why we didn't do that on the first one, there wasn't any perpendicular line to drop because that wasn't about to make a triangle no matter what we did. Okay? So those we actually like it the best because you don't have to do a lot of math to it, but here we go. Now, as I've mentioned it before, your calculator doesn't have a bearing mode, which means we kind of have to do that math for them. So your calculator only knows interior angle. By interior angle, I mean, you see this triangle that we just drew? Within that, the interior angle is inside, closest to the x-axis. So that's your interior angle. So when we are calculating this, your calculator only knows how to calculate it with that angle. So based on this, since this square part, one quadrant is 90 degrees, my interior angle of this triangle is 20 degrees. I know that because there would be 90 minus 7 degrees on that. Okay. The reason why we need to know is since this right here, we drop the perpendicular line on purpose because that's going to make a right triangle. So what we can do is right triangle trick. On that triangle, from that 20 degrees, this is my opposite, and this is my hypotenuse, and this is my adjacent. Now, once again, this adjacent, since it's horizontal distance, we refer that to x distance, and this opposite, since it's vertical distance, we refer that to y distance. Now, because x comes before y, I kind of like to find x first. We'll do some math here on the side. To find my x, I am going to have to use, this x, this degree, and hypotenuse, which we know hypotenuse was this. So let's use that. So cosine, because x represents, cosine represents x. Cosine of 20 degrees is equal a over h, which is x over 6. I'm isolating x by itself, so I'm going to multiply both sides by 6. We get x equal 6 cosine of 20 degrees. Now we're going to put this in the calculator. And make sure your calculator is in degree mode. You check it by doing this. Click mode. And the blinking light should be down at degree. Press enter. And you get out of the by pressing clear. So what we'll do here is we're going to go ahead and plug this in. Your x is 6 cosine 20. So we put 6 cosine of 20. And that's going to give us 5.638. Okay. And I like to round it to 3 digits after the decimal point, so that's what we get. So my x point is 5.638. Now I'm going to do a similar thing and find my sine. So my sine is O over H, so it's going to be opposite over hypotenuse. So let's do that. So sine of 20 degrees is opposite, which is y, because sine goes with y, over hypotenuse, which is our distance. Once again, we're going to multiply both sides by 6 to isolate our y. So our y is equal 6 sine of 20. So let's put that in, 6 sine of 20 degrees. That's going to give us 2.052. 2.052 is our x point. So I'm going to pause and see what all we got. We got our vector u and we got our vector v. We can get those little corner points by using SOHCAHTOA, or if it's just a straight line going up, down, left, or right, you can just read the corner points on there. Now once we're done, I know the direction is not written on number 1, but I'm going to go ahead and give the directions to you. It is for you to go ahead and find the resultant vector. If you remember, we find our resultant vector, and we were going to express it as R, by adding all the vectors. Adding all the vectors. Okay, that's how we're going to find our resultant vector. So let's take a look at that. The resultant vector will be adding these two together. So we're going to add the x points together. So it's 0 plus 5.638. So it's going to be our R is equal 5.638 on our x's. Okay. And then we're going to also add our y points together. So it's going to give us 13.052. So that's my resultant vector. Good. Now let's try to graph it and see where it is. So on our thing, on our axis, this is telling me that I'm going to go to the right because that represents x coordinate and that represents y coordinate. I'm going to go to right 5.638 and up 13.052. So that's where that's going to end up at. So we start at 0, 0. It's going to end up there. Right there. Okay. Now let's see. So I'm going to drop the perpendicular line. Okay, here's what this means. We're saying this x distance here is 5.638, as it says up there, and my y distance is 13.052. Now, once we got here, I know this is a really long problem. What we're trying to do is we're trying to find the distance of our R and also find the angle of our R. Well, we're going to one thing at a time. We're going to find the distance of our R by using a Pythagorean theorem since it is a right triangle. So we'll do a squared, which is 5.638 squared plus b squared equals c squared, which in this case our R squared. However, I'm looking for my R, so I'm just going to square root both sides, which gives me square root of 5.638 squared plus 13.052 squared is our R. I'm just going to put that in the calculator. So we'll say square root of parentheses 5.638 squared plus 13.052 squared, and that gives us 14.218. And that gives me the magnitude of our R, the distance of our R. One last thing that we have to find on our R is the angle. And here's how we find it. You see it from the angle that we have. That angle is going to be found by using a tangent, and it's always found by that tangent. So theta is equivalent to tangent inverse of y over x, which is 13.052 over 5.638. So let's put that in the calculator. So tangent inverse of, if you do green button, the alpha y equal, it gives you a fraction button, so I'm just going to do that there. It looks easy in my eyes. 13.052 over 5.638, and that's going to give us 66.637 degrees. Now let's take a look here. That gives me this theta right here, which is 66.637 degrees. We would be done if we were in a bearing mode. However, we were in a regular mode. However, we're in bearing mode. My bearing mode always starts at 0. So when I measure this angle, it needs to start at 0 and go all the way to this blue line. So that's not going to be 66 anymore. So we need to subtract that 66.637 from 90. So we'll do 90 minus that number It's going to give us 23.363. Alright, 23.363. Okay, and that is your actual true theta of your resultant vector based on our mode, which is varying mode. So what we were looking for this entire time was the magnitude of our R and the theta of our R in varying mode.